Hello all. In this class, let us discuss about doubly linked list. First of all, let's see the definition of doubly linked list. Okay. A doubly linked list have data field where we store the value or actual content, and it has two link field. One is to store the address of the next node, and another one is to store the address of the previous node. Okay. That's the difference between a single linked list and doubly linked list. In single linked list, there is only one link field to store the address of the next node only, whereas in doubly linked list there are two link fields. One is to store the address of the next node, and the other one is to store the address of the previous node. Okay, this is a general representation of a node. Okay, it has three fields, one data field. Here this is a data field and two link field, next and previous. Okay, here the next is used to store the address of the next node, and previous is used to store the address of the previous node. Okay, now let's see structure of node. Okay, this is structure of node. There is three fields, one data field and two link field. Okay, here nodes next or node previous are two pointers that acts as a link. Here the next is used to point to the next node. That is, it stores address of the next node, and previous is used to point to the previous node. That is, it stores the address of the previous node. As in the case, as in single linked list, in the case of doubly linked list, also we are using a special node called head pointer, or you can say simply head. Okay, this head is used to keep track of the entire linked list. Initially, head pointer is set as null. Okay, create node is a function that will create a node and will return the uh, address location of the created node. Okay, now let's see a simple representation of a doubly linked list. Okay, there will be a head part. There will be a head, okay, and one node like this. Node. Let us assume that there is only two nodes, and this node is the and this is the last node. So the next field of the last node should be null. So we are setting it as null. Okay. Here also there are two fields, three fields, one data and two links. Let let the value here be 10. Okay. The value here be 20. Okay. Let its address location is 100. Or no, say 200. 200. 200. Okay. Its address location is 300. Let's assume. Okay. Now this is the head node. Okay, let its address be 100. Okay. This is the first node. Okay. Its address is 200. This is the second node. Its address is 300. Okay. Let's here the next previous field of this node. In the previous field of this node, the address of head will be stored. That is 100 will be stored, and the next field, the address of the next node, that is 300. will be stored here. Okay, here also in the previous field 200 will be stored, and the next field null will be stored since this is the last node. So we can say that the next field of the last node will be always null. Okay, this is a general representation of a linked list. Okay, now let's see the discuss the operations of singly doubly linked list. Okay, basically there are two operations: insert first and insert insertion and deletion. Okay, in the insertion part, there is different ways of insertion. One is insert first. Here we are inserting the node at the beginning. Then insert last. Okay, we are inserting the node at the end. Okay, insert after. Inserting after a certain node. Okay, insert before. Inserting the node before a specified node. Okay, that okay, that the position of node will be asked by the user. Now let's first discuss insert first. Insert first, as already told, it is used to insert value at the beginning. First of all, we have to create a node. So this algorithm for insert first, uh, new node is equal to create node. Create node will create a node and return the returns the address of that node. That node address will be stored in new node. We have to store some value in the data part. So we are giving new node of data is equal to value. That means in the data field we are storing some value. Okay. Okay. Now there are two conditions here. First condition is head is null. If head is null, that implies that the list is empty. That means the list has do not have any node. So we have to we have to assign the address of that node to head. Okay. Let's see. First condition. Okay. Let's see the first condition. Initially head is null. Initially head is null. Head is null. Okay. Address is 100. Initially head is null. Now we are creating a node. Let me create here. We are creating a node. Let the data be 10. 10. Let its address be 200. Okay. Its address is 200. Now what's the next step? Head is equal to no, head is equal to new node. Okay. We have to store the address of new node in head. Right. Okay. Okay. The head points to this one. Head points to this. Okay. So here in head part, the address of this node will be stored. That is 200 will be stored here. Head points to the first node. Okay. Now what is next step? Head of new node of next is equal to null. Okay. Since this is only node, we have to set the link next field of the new node as null. And the previous field of new node, we have to store the address of head. Okay. Since here head act as a previous node of this new node. So we have to store in the previous field of new node the address of head. Okay, let's see how. Okay. Next field of the new node is set as null. Okay, like this. And then previous field of this new node, in the previous field of the node, address of head is stored. That is 100 is stored like this. Okay, this is the first case. Now let's see the else part. Okay, and else part, it says that um, else part implies the head is not empty, that it has at least one node. Okay, so we have to insert this new node before that node that's already present in the list. Before that node, we have to create. We have to insert another node. For that, insert. So it's called insert first. Okay. So we are creating a node there, and in the new node of next part, we are storing head. This says that the head points to the node. Mm, It points to that node in the list. There's only one node that head points to that node. So we have to store. I'll show you 1 minute. Here, this is the node to which h is pointing. Head is pointing. So in the new node of next field, we have to store this 200. That it means. Okay. Here we are creating a new node. Hmm. Let the value here be 20. Let its address be 300. Okay. This next field we are storing the head. Okay, head points to this node. This node 200. So we have to store here 200. Okay, 200 is stored here. So what is the next step? Head of previous is equal to new node. That means that means in the previous field of this node we have to store the new node. That is 300 we have to store here. So here we have to store 200, right? We have to store 200. No, 300. 300 is stored. Now what's the next step? Next step, head is equal to new node. That we have to make head pointing to the newly created node. So the address of newly created node is stored in head. Okay. Okay. Now head points to this one. So we are erasing this link, connection. Okay. And now head points to this node, right? Head points to this node. So we are doing the connection. Okay. Now head points to this one. What's the next step? Okay, new node of previous is equal to head. In the previous part of new node, we are storing the address of head. Okay, we are storing 100 here. Okay. Okay. Now, between this and this node, there is a connection. Let's go first, like this. There's a connection. So this is an insert first. Okay, the new node is inserted before the node that was already present in the list. Okay, so the now head points to this node. 300. In the previous field, 100 is there. In the next field, 200. That is, the address of the next node is stored. Here also, uh, in previous field, address of the previous node is 300 is stored. In the next field, null is stored since it is the last node. Okay. This in this way, this is how insert first works. Okay. Now let's see the insert last operation. In insert last, we are inserting the node at the end of the list. Okay. Here also first we are creating a node. New node is equal to create node. This creates a node and address of that node is stored in new node. New node of data is equal to value. Here we are storing in the data field we are storing some value. Okay. First case is that head is null. Okay. This is similar to that we have seen in insert first. Okay. Similarly, if the head is null, if the head is null, we have to create a node and assign head the address of that node. And we have to set the new node of next is equal to null and new node of previous is equal to head. Okay. Now let's see the else part. Else part says that the list is not empty. So what you have to do? You have to find the last node. Okay, and insert the new node after that, after the last node. Okay. Okay, initially there is a list, linked list. The list is not empty. Let that list be this one. There are two elements. There are two elements. Let us assume that this is a linked list. Okay, there are two nodes. Hmm. Okay, first of all, for the else part, first of all we have to find the last node. Okay, this is not last node. So what is the procedure? Let's see. This is the list already existing list. Assume that this is already existing list. Okay. Hmm. First here we are using a current. We are using a temp variable called current. Keep track of the entire linked list. Okay. Okay. That for find especially for finding the last node. First of all, current is equal to head. That is current is set as head. Since head points to the first node, the current is equal to uh, the address of first node. That's all. Now let's see how it works. Okay. Initially current is equal to 200. Okay. Current is equal to 200. Initially current is equal to 200. Okay. Now let's see next step. Okay. Mm, okay. While current of next not equal to null. Okay. This we use a while loop to find the last node. Okay. We are checking whether the current of next part of current is null or not, because that's a specialty of last node. The last node, the next field will be null. So we are checking current of next is null or not. If it is not null, then we have to go to the next node. So we are using current is equal to current of next. Now in the list we have, let's find the last node using these steps. Come on. Okay. Now current is 200. Checking current of next. That is current of next is 300. So it is not null. So what you have to do? We have to move to the next node. For that, now we have the current is equal to current of next. Current is 200 and current of next is 300. So current now becomes 300. Current now becomes 300. Okay. Current now becomes 300. Okay. Now let's store 300 here. Okay. Current is equal to 300. Now again checking. Okay. Mm, Now initially current is equal to 200. Now current is equal to head, so current is equal to 200. Okay, now checking whether current of next, that is 300. Okay, current of next is 300. Hmm? So it is not null. So what you have to do, we have to go to the next node. So current is equal to current of next. Okay, current is 200, current of next is 300. So now current becomes 300. Current becomes 300. Let's do that. Okay. Mm, mm. Current is equal to 300. Now again checking whether current of next field is null or not. Okay, current is 300. The next field of 300, that is current, is null. So this is the last node. So we found out the last node. Now let's see what's the next step. If there is extra nodes, then these steps will be repeated until the mm, until we reach the last node. That is the node whose next field is null. This step we have to repeat these steps if there are more nodes. Okay. Now we have found out the last node. Let's see what's the next step. Mhm. Now we have found the last node. Current of next. In the next field of the last node, we have to store the address of new node. Okay. Then we have to store the next field of new node as null. Now let's see these two steps. So we are creating a new node here. Let it be here, new node. Okay. Here like this. Here the let the data be 40. Let its address be 400. Okay, let this address be 400. Okay, address is 400. New node is created. Then we have to set the next field of new node as a null, like this. Next field of new node is set as null. Now we'll see the next. Now let us see the next step. Okay. Now we have to store a new node of previous is equal to current. In the previous part of new node, you have to store value of current. Okay. Now let's see how it works, how it looks. Mhm. And then in the previous part, you have to store the address of current. That is 300 is stored here. 300 is stored here. Now, uh, okay, here in the next field of 300, we have to store the address of this node. Okay, here we have to store. That's the next step, I think. Here we have to store the address of this node. Okay. Uh, so let's see now. Okay, here 400 will be stored. That means now this node points to this node, like this. Okay. Mm, yeah, that is done. In this way, insert last can be performed. Okay. Again, let's see. Okay. Now the last node has been inserted at the end. Okay. Now head points to this node. The previous field we are storing address of head. Next field we are storing address of next node is 300. Here also in the previous field we are storing the address of the previous node. The next field we are storing address of the next node. Here also like that. In the previous we are storing the address of the previous node is 300. The next, since it's the last node, the next field will be null. Okay.